How are we doing? So I'm going to be talking about our experience with Bionic One Exoscope digital microscope. It's an augmented reality microsurgery platform, which is kind of interesting because today we have heard mostly about gene therapy and different medication modalities and treatments and concepts. And I want to answer at the end of this presentation, why is this valid in this setting? But before that, let me explain what we're talking about. Bionics One is a microscope device developed in Israel. It's an offshoot of military technology that, and where's the, here you go. So this is the microscope. This is the head where the digital unit is. And it basically presents your images to a head device that allows you to perform surgery with augmented reality, fully immersive system. In addition to the immersive system, the headset, and you'll see it in a second operation, has gyroscopes that allow you to control the microscope with head gestures, focus, brightness, panning, and different other things. And it's in a way a new way of going into the operating room and proceeding with surgery. Hand visualization, on-demand consolidated preoperative information, accessible during surgery in an immersive augmented reality surgical headset. So when you think about surgery, and I mean, there's a lot of surgeons in here, but there's some others that are not surgeons, and this is a question of ergonomics. When you're performing surgery on a microscope, on a standard optical microscope, you're in a way tethered. And I always think about the tethering being a vertical tethering, basically that your height from your eyes to the surgical bed is standard or with minimal movement. That requires you in a full surgical day to be maintaining that same position throughout the surgery. If you move on to other digital platforms, which are great and out there in the system, which are platforms like, sorry, let me go back. Platforms like these ones where you have a screen in the operating room. Now you have what I call angular tethering, in the sense that your head has to be looking in a specific direction throughout the whole surgery to maintain visualization of this. So that produces an angle where you're not looking straight forward. In addition, you have a second angle, which is the angle of your eyes. You have to be at the same horizontal plane that the stereoscopic visualization is being presented when using a screen. So you are untethered on the screen version from a vertical standpoint, but you're still tethered on what I call angular standpoint. When you use this device, you're untethered in the sense that you can position any position that's comfortable during the surgery. You can lean back and still basically do your surgery. Now, the question of ergonomics is interesting. I think it's important. I think it's interesting and cool. But I think there's more to this than this. And let me go back to the machine itself. Again, this is the camera head unit. 2700 degree rotatable, so that means that you can go basically on each direction, so you can perform surgery on each side if that's what you prefer to do if you're doing cataract surgery. Over 8K resolution, clear images, LED-based illumination system when you see it on your screen. You have a motorized arm. This is fairly straightforward, and the user interface with the touch screen here. Now, interestingly enough, the user interface, which is on a touch screen, can also be utilized with your head gestures. So you can basically program your head gestures to decide whether you're going to be changing modalities and filters and in different ways to interact with the device. To put it into perspective, how do I start this video? Can you start it, or do I start it over here? Oh, there it goes. So this is an unedited, I edited the clips, but it's not edited in terms of quality of the imaging. And I just wanted to show the visualization. Here you have preoperative OCT images. This right now doesn't have intraoperative OCT. That's a future concept. But I just want to show the quality. This is one of the first surgeries with this device. FYI, I think about 1,200 surgeries have been performed worldwide with this system, so it's not totally brand new. On the Retina side, I think it's been around 200 surgeries. I may have performed about half of them. So they asked me to talk about this because I've done a few. This is just to show the quality of visualization. And this, if you look at these things that are coming up around the screen, these are, on your image, it's telling you when you're changing filters, when you're changing, see focus via headset, I'm focusing in and out, and I'll show you in a second how this is operational. But the concept here is to change how we perform surgery. In addition, So here we go. I mentioned ergonomics, but I'll point it out again, that I think all of ophthalmologists that are doing a lot of surgery, we basically know that our back hurts often. And I'm one of those personally. And it's a fairly common problem in our specialty. But looking at here, this is how we perform surgery. There's no visual connection, no optics between the device and me at this time. This is the biome system for indirect visualization. This is the camera. And otherwise it's perfectly standard. You can, while you're doing the surgery, click a button and go into what's called see-through mode, where you can now basically see the room. But when you're in the operating mode, you're basically fully immersed. And as a surgeon, you're basically seeing all around, and you can pan up within the field that you're operating. Now, to put it into perspective, how can this allow us to interact with other surgeons? I think Carolyn Bauma was here earlier. She's one of the co-directors of the course, and that's Carolyn right there. So this is me in the operating room, and here I am talking to her with this little device. This is a monocular diabetic tractional detachment, and she was able to follow the conversation. We're able to real-time interact and say, hey, what do you think about this? Would you dissect here? Would you do this? Would you not do this? On real time. This is basically a proof of concept of what we can do in terms of collaboration. But I also wanted you to see the layout of the operating room and how little real estate this device utilizes in the room, and how we're able to perform our surgeries. My team in my room is not exactly the most sophisticated. Don't tell them I said that, they're very sweet. But they're able to incorporate the device into their operations without any trouble, so I'm really proud of that. So that's what I'm talking about, the engagement. You have this touch screen, the rotating touch screen, everybody in the room can see. Up to 3 people can wear the headsets, so they can have the same experience as you're doing the surgery. And allows for an interesting concept. But I want to perhaps ask a different question, and I mean, this is standard things that going back. I guess the question is why? Why do we need this? Are we good enough already with our visualization? I think we are. I mean, we do quite a bit of surgeries as we do, and interestingly, very little surgical work has been presented today, because it shows that we've kind of reached a plateau in what we can achieve in surgery, at least in our standard vitrectomy surgery. And when you hear, I've been an investigator in gene therapy trials with retinal injections. I'm an investigator in port delivery systems. And when you hear about these studies, you hear one common theme is how to manage variability between surgeons, how to manage some form of conservative way of providing data and providing quality control across locations. That's one point that I think this platform allows us, any digital platform in my opinion, but this one in particular allows us to move forward. The second concept is, so again, the discussions that we had earlier have been mostly about intravitreal injections and suprachoroidal injections and subretinal injections. But I believe, and I think one of the financing people was talking about this earlier, that as we move forward from gene therapy into cell therapy and hopefully at some point into tissue therapy, we're going to have to figure out a way to interact with tissues in a way that we currently don't. Okay, in our standard visualization, coming up and down on a z-axis may not be sufficient to access the submacular space to do more interesting procedures for transplanting RPE or whatever it is that we want to do. So I believe that to move forward our surgical technology so that the biotech world and the medtech world are able to collaborate, there's 2 things that need to be improved. One is visualization, and the other one is, somebody mentioned robotics. Well, this is the concept of, I think, a platform. From a surgeon perspective, the first question is, can you replace the standard microscope? The answer is absolutely yes. But I think what I find more interesting is what's going to happen in the years to come, when now platforms like these can totally revolutionize the concept of regenerative medicine in the ophthalmology space. So just to finalize, enhanced visualization platform, it allows us to filters, allows us to basically find things that would otherwise be difficult to find, like small little retinal tears in the periphery by edge enhancement, advanced ergonomics, efficiency in the operating room. And that's what I had to say. Thank you very much.